We did that on Talos platform from Raptor. And yeah, thank you for coming. Who am I? I'm Piotr Król. I'm 3MDEP founder and CEO. I'm open source firmware and open source hardware promoter. I also very interested in integrating trusted computing technologies. I'm conference speaker and organizer. I'm also Trendboot steering committee core member. Trendboot is a project related to dynamic root of trust for measurement. This is trusted computing stuff. So if you are interested, please Google. I'm 13 years in business, 7 years promoting open source firmware and trusting computing technologies, and currently C-level position in 3 organizations, where one of them is 3MDEP. Who is 3MDEP? What we're doing? We are a Coreboot licensed service provider since 2016, and also leadership participants. We are UEFI adopters since 2018. Yocto participants and embedded Linux experts, official consultants for FWPD LVFS Linux Foundation project, and also IBM Open Power Foundation members since last year. Yeah. So what we will talk about, we will start with why we even doing that. Of course, like starting with some kudos, but then why we even doing that? What was our workflow? What we struggle with? What were our problems? And mostly, I would say, complaints at this stage. What we did so far, and what problems, and how we work around them, and what kind of plans we have for future. So first of all, I would like to thank Thierry Laurion and whole Insurgo Technologies Libres Open, Canadian company dedicated to privacy, and because they founded this project, they founded the development of Coreboot for POWER9, the port of Hostboot to Coreboot. And of course, whole 3MDEP team, especially Christian Hebel, and I hope Christian is here today with us. Christian is firmware engineer at 3MDEP, and he was main contributor, and most of the stuff done in this port was done by him, and I hope he will help me with questions if some advanced question will rise at the end. Igor Bagnucki, junior embedded firmware developer who supported Christian, and Maciej Pianowski, engineering manager who oversee all effort and drive that from managing perspective. Okay, why even to do this? First of all, Hostboot is very complex. It's a full-blown OS. It has virtual memory management, paging, user space, interrupt support. Even it swaps memory back to flash before RAM is trained. Yeah, so it seems like 10 megabytes of L3 cache is not enough. Because of boot time, we would like to improve boot time. Of course, for some servers, it really matters, the cold boot path. But yeah, if you are hyperscaler on power, or you have a lot of power machines, any downtime is painful. So we want to optimize that. And finally, POWER9s like Talos II are more workstation platforms. And because of that, I believe users of workstation would like to boot the platform as soon as possible. Other thing is code size. Smaller code means faster loading, faster validation, no swapping, less maintenance overhead, less bugs, and so on and so on. I believe every developer like smaller code base, which does the same, and then bigger code base, which is complex and like a spaghetti. And yeah, so we wanted smaller code base. And also we may get through smaller code more space for other components. We can buy cheaper flash, but this is maybe negligible for so expensive hardware. This is also benefit for Coreboot community. First of all, there is new architecture supported. There was power support back in the days, but yeah, it was neglected, and definitely this helped growing the Coreboot presence in the open source firmware ecosystem. Yeah, we also checked the code of Coreboot against NDNS issues. We found some stuff, we fixed it, and that's also benefit for the community. And yeah, and we got new open platform in the Coreboot code. Not yet, but we will upstream it. We are on good track. On the other side, why Insurgo did that? Insurgo did that because they already have well existing product based on Coreboot heads and CubesOS. and they wanted to add something to that portfolio. On the other side, Coreboot is well-recognized firmware platform with sizable community. There is a lot of support. There is great Slack where discussion with over 1,000 participants discuss open source firmware based on Coreboot. So I believe this is also benefit. Yeah, so about the comparison of binary image sizes. So as you can see, Hostboot files weight more than 15 megabytes, and SCIboot is placed in different partition. And in comparison to Coreboot, what we were able to achieve, we have around 2 megabytes, and we think when compressed, it would fit even to Hostboot bootloader. It includes uncompressed SCIboot as a payload. A payload is a concept in Coreboot, like a kind of bootloaders and all the other stuff is treated as a payload. Coreboot just do basic initialization and try to be minimized. We still have around 315 kilobytes free space in Coreboot file system. Yeah, and whole CBFS, so whole Coreboot file system, including payload, fits in one pinor partition, which is like means way smaller footprint than Hostboot. In case of boot speed, this is comparison of boot speed that we were able to get. So release version of Hostboot from CPU start to SCI root is 63 seconds from our measurements, at least for our configuration. Debug Coreboot from CPU start to SCI root is like 42 seconds. It's like 30% of gain. If we disable debug output, serial output in Coreboot, we can go down to 36 or even 34 because we can still optimize stuff. So yeah, so this is some gain on the boot path. Maybe a little bit like what we challenged, what problems we had with porting Hostboot code to Coreboot. So it looks like the code from one side is advertised as open source firmware, as open, but the problem is that quite a lot of this code is machine generated, and it seems to be generated from so-called init files. Those init files are not included in the Hostboot tree. We found like something that was left, and on the bottom on the screen of the slide you see sample of this file. It looks like those files are not public. We have no idea what's the spec for those files. We have no idea where we can find compiler for that path, for that files. So that's kind of what was challenging for us. Hostboot got huge code base. It's like 1.7 million lines of code. It's like a lot. C++, XML, Perl, and various other stuff. And yeah, so we did, like we can say we did code audit of Hostboot because we have to port all the necessary stuff, or at some point it was even reverse engineering because there was not enough documentation. That means like we had to like ask the question what author had in mind and like kind of try to follow different paths to resolve and reverse engineer some concept behind Hostboot because there was not enough documentation for that. Some code is, to be honest, terrible, like in terms of reading, because it's like machine generated, barely human readable spaghetti code like this. Like if you're reading this, there's like, I don't know, like who can read that with understanding. But that's some part. There were also some problems with implementation. So this is example of rounding the numbers. Of course, this will just discard most significant bit. This was introduced in massive code refactor of 5,000 lines of code with 4 reviewers and 6 testing systems that didn't catch like this kind of problem. And of course, like we know that everyone make mistakes, but bigger code base, more problems during the maintenance. Next thing was doing floor like this. So this doesn't seem quite right. Of course, of course, this will break for higher precision values, like 0.99999 will give us -2, which is of course incorrect result. There are also some weird constructions because of the machine-generated code. And of course, the problem, if you don't know that, the problem is that else if is not enough in this case, and there is use of this negation in the else if statement, which is weird for human programmers and probably not so weird for machine generated code. Sometimes there is lack of consistency, which can cause problem if someone is not careful enough. So sometimes we're doing setters with ID and value, and other setters we do with value and ID. Then context of code, like when we did the implementation, the context of code was very important. And to be honest, to effectively do the analysis of given paths in the code, we could give that only to one person. So one person have to do that, the given context, because otherwise it was hard to exchange information between multiple developers, because those paths are so complex and understanding that is challenging. Yeah, so a lot of time was spent on understanding basics like FIP buffers. Yeah, so we saw documentation. Of course, there is some documentation, but the examples were so basic that in comparison to code, how it was used, we couldn't kind of understand, and it took time us to understand how this really works, because the examples didn't explain more complicated methods of using that. There is also C++ mixing of templates and methods of classes, and yeah, so that's additional problem, additional complexity. Yeah, so porting without proper documentation is error prone, and yeah, so you should test any code that we ship if you want to try to use that in production. What we need, we believe we need Hostboot documentation, like comprehensive Hostboot documentation. First thing is in code, in source code. There are some places where documentation is not bad, but there are other places that make this hard task to port it to Coreboot, and took very long time. Also, the standalone documentation that kind of describe high-level concepts and give introduction for, let's say, new coming developers that would like to contribute to project. So we documented as much as we could. There is repository on GitHub, open power Coreboot docs on in 3M Dep organization. We highly recommend dev notes porting Markdown. And yeah, if you find the mistakes, please issue a PR or just let us know through various channels that I will mention at the end of this presentation. Other problem that we faced was Ascom registers. So Ascom registers are a very basic system for any operations in Power. The base address for this registers is set by self-boot engine at the beginning. And to be honest, we used a lot of guesswork and kind of reverse engineering to figure out how to use Ascom registers. Luckily, people on Open Power firmware mailing list were very helpful. And in addition to that, we have to thank Cedric for implementation of POWER9 in QEMU, because this helped us to understand how Ascom registers work. What's the problem with this Ascom registers? So there is over 11,000 documented registers, but not all of them are documented, and it looks like Hostboot used some undocumented. We discovered over 500 undocumented registers. The documentation sometimes is inaccurate. We found some registers that were used differently than documented. Sometimes initially we didn't even know how to access Ascom registers. This was poorly documented. For example, here on the bottom we have some graphics showing example of confusing Ascom description. You can see that the name is kind of hard, like it's meaningful. It's like error, C error, and only I don't know who would know what this means. Probably someone who initially implemented that. The purpose and definition is hard to understand. And more to that, all the bits are reserved. So yeah, our error register can be used without knowing what the bits mean. Yeah, those are some examples. Access to Ascom registers can be direct and indirect. Indirect access was documented only by this graphic, which is like not enough to create working implementation. Eventually, we did some implementation, but we didn't know that using indirect access cannot be done at early I steps. So yeah, that was also something that was mystery for us, and we detected that further in the implementation. Another challenge was memory initialization. We probably spent most time on that. Maybe occC plus Homer was comparable in complexity, maybe not in time. This was time when we learned how to access Ascom, how to do I-step dispatching, and what's the Hostboot directory structure. Like, we learned a lot at this point, and that was why it took a lot of time for us. We found some small issues with memory data format. Of course, like when you messed up something incorrectly, then you end up in completely not working implementation, and you have no idea why. At this point, we discovered PDBG, which helped us in getting through that problem. But we thought that we failed because we don't understand DDR initialization well. So we even bought JDEC DDR specification, and this happened to be a waste of money, because all the information later we realize can be found on vendor site. So lesson learned: do not buy JDEC specification unless you really know you need it. On-chip controller complex was another big thing for us. So it's very complicated. It contains multiple general purpose engines, which you have to initialize. You have to provide code for it. So each component in occC complex got separate local area with different format, which we didn't understand initially, and there was no documentation at all. So we kind of reverse engineered that, and step by step through various methods we get through and were able to initialize it. It is required to enable power management in the OS and starting other cores. Yeah. So and the other thing was Homer. So Homer is another big piece of code. This Homer is hardware offload microcode engine region, and it has few hundred fields that had to be properly set, and there is no documentation. It is divided in 4 regions, 1 megabyte each. So you can realize how much data it is. Some of that is read from PNOR as is, but a lot of it has to be calculated or crafted some way. So from our perspective, when we look at occC plus Homer in Coreboot, around 8,000 lines of code was even more than memory initialization, which was around 7,000 lines of code. And of course, we would be glad to compare that to Hostboot, but there is no way to do that, because this implementation in Hostboot is spread around multiple files, around multiple places, and yeah, we even cannot compare that, how much it takes in Hostboot. Yeah, documentation is scarce and sometimes laconic. Homer and Ascom details were provided as a result of main lengthy discussion. So first of all, we should make sure that we don't afraid to ask questions. Sometimes it is hard to find things, but sometimes if we get through corporate approval process, we may get after a couple of weeks some important documentation. In Hostboot, it looks like code is documentation is the approach, but yeah, we hope to change that with 3M Dev-Arrow product line, which would be delivered with Insurgo Talos workstation. So yeah, On the other side, we also saw situations in which code comments this mismatch the code implementation. So it is worth to read the code and not use function before understanding the implementation. Reading Skiboot, QEMU, Linux source code gives way more information than sometimes reading Hostboot code. And here we have some example on the bottom. This graphic shows fragment of APC master error report register documentation. It is just a fragment because whole register definition takes 2 PDF pages. So this is huge register, most of the values reserved. So this is another case where documentation could be better. Okay, so how Hostboot implementation compares to Coreboot implementation? So first of all, we choose different way to pass data between Hostboot and Skiboot, and Coreboot and Skiboot. So Hostboot using some unknown format HDAT. At least we didn't get any documentation how to use that format, and we thought that using flattened device tree, which we have experience with from the embedded projects, would be way better. So we used flattened device tree for Coreboot. Coreboot always reads MVPD from EPROM, and this of course slightly slows down the boot process. So if we could have cache or some way of not reading it, then we will speed up the boot process. And on the other side, we always have fresh data, and we are concerned if Hostboot validation through just checking serial number is really trustworthy and it's good enough for when we're fetching this data from. So we also decreased the number of passes of RAM pattern testing to improve boot performance. We didn't saw any malfunction because of that. Maybe we will kind of make it some parameters, how many passes are good enough. Hostboot do more pattern testing iterations. We plan to replace Petit boot with heads, which is like very similar concept. Heads also use kexec to start further operating system. We also changed some steps. Most of the steps in Hostboot are dedicated to data acquisition, and in Coreboot there is no such a concept. There is no such a need. So all the data are acquired when needed. iStep 16.2, which starts secondary cores, was moved to just before jumping the payload, and this hack removes the need to implement sReset handler and so on. So these are technical difference that we did. So I want to show you BMC serial log that's showing the boot process. I just hope that. Do you see do you see the screen still with the boot process?
Yeah.
Yeah, we can see it.
Yeah. So it's booting. So you see Coreboot ROM stage.
No, you have to click the play button.
Stacking is like buffering, serial buffering.
No.
Oh, you don't see my
H code is in 001 through 00 something else, and there it stops.
So for me it's playing. So you can see that.
We can see just the presentation.
Yeah, it's just a still, but I see an ASCII enema link at the bottom, so we can follow that.
Okay, let me try to maybe like this. What about now?
Yes, that looks a lot more lively.
Yeah, that's working.
Okay, sorry for that. Like I have cloned Windows, and that's why. Yeah, so we booting. Yeah, and we have ROM stage. running. Yeah, and Skiboot. Now switching to skiroot. This second will be quite fast. The decompressing takes time. And finally, we will get petit boot. Yeah, and from now on, we just have to, let me try to get to the presentation. Okay, do you see the presentation now? May I continue?
Presentation. It is a presentation slide. I'm not sure that's the correct one.
Yeah. So there should be to do slide 25.
Nope.
Okay, let me try. Okay, sorry. Like let me try to share screen again.
Yeah, that looks more like it. In no particular order. Now it seems that you are on mute. I cannot hear you.
Sorry for that. So there is new feature in Chrome, share tab audio, and if you do not unmark that, then you're losing audio from for other tabs. What about now? Is it voice working and you see the presentation?
Yes.
Okay, so to-dos in no particular order. Code cleanup. So we would like to make Coreboot less verbose. Definitely organize documentation better. Of course, this is matter of budget, we already way over budget. So, so I don't know how much we will have for that. There are some hard-coded device tree things which we want to unhard code. There are some already some subtrees already created by code. There are some removed one, and yeah, there are some cosmetic things that we want to change here. We would like to support systems with 2 CPUs installed, because right now we're just like doing things with booting with 1 CPU. Definitely some testing, more testing, and you know, if you want to volunteer testing, definitely we need testers because like that we cannot handle all the checks ourselves. Some other, like maybe less important or maybe with lower priority. First stage of Coreboot called bootdog can be put in as EEPROM, which would add, and the benefit would be validated, verified, measured boot. So I believe we want to do that. Coreboot on different components, like this is some discussion on if we can put Coreboot in cellboot engine or OCC. Yeah, so this is similar discussion to what's going on in Coreboot community about putting Coreboot in trusted firmware or whatever. And I don't know if this will go in this direction. Definitely we would need compiler for that. And yeah, this may complicate things even more. And the question is if this will fit Coreboot's design. Right now, memory training values, like we should make memory training values cached between boots. This could do faster boot, of course, but we don't know if this makes sense. If this will be big enough benefit. There are some things that you could see in logs that there was complaint about versions in Pinor. This is because device tree node IBM firmware version is not exactly recognized, and there are some hard code stuff still there. which we would like to improve. And that would be mostly it. Where you can get more information, we holding community biweekly call every odd week, so work week 43, 45, and so on at 2 p.m. UTC. There is a link here for the call. This is on our Jitsi. Like right now, there is no crowd there, so rather our Jitsi will survive. And there are minutes, public minutes that you can go in RiseUp see what we're talking about, what's the progress, what's the issues, and feel invited to that call. There's also open source firmware Slack and channel on this Slack, Open Power, and feel free to register to that Slack. There are many people interested in heads in Coreboot on Power. There are also our repositories. Feel free to go there, compile stuff, or just use ready-to-use binaries on your platform. If you will see any problems, feel free to report issues. Eventually, we plan to move everything to Dasharo infrastructure, since this would be kind of branded as a Dasharo, which is our open source firmware, you can say, distribution or set of tools that help us create a firmware. And under documentation, we will have all needed information organized in way better way than it is right now. Also, like binaries to download and flash, and some information about testing, what was done and what really works. Yeah. So if you like what we do, if you like the presentation, and you would like to support us, feel free to do that. We can do a lot of stuff related to Hostboot and Coreboot and open source firmware for Power and other related platforms, because like using this exercise or research of more porting Hostboot to Coreboot was a lot of learning, and definitely we delivered that. What we can do, we can improve Hostboot documentation or even help maintain it if that's something that we could deliver. Firmware validation, trainings for new beginners, code audits, which we did like a little bit of code audit for Hostboot, and we can do more. I believe this code deserves some audit because it's a lot of it, and definitely it would not be easier over time to maintain it. Definitely some platform bring up and custom features development is something that we can do. Yeah, and if you want to talk with us, we would be glad to try to convince you to switch to Coreboot from Hostboot. But you know, like the world is full of choices, and you can just like check what works best for you. So thank you for watching, and thank you for listening of this presentation, and I'm open to questions.
Hi, this is Todd Rosedahl from IBM. We talked a few times. I'm the architect in charge of the OCC and Homer and all that good stuff. I guess my question is, how did you set this up just like Hostboot, in that, like, if you wanted to support a 2-socket from a 1-socket, you can just do enter a different config file, or is it going to be more difficult to support different configurations, different memory layouts and whatnot?
Yeah, that's a good question. I'm not sure if I get enough knowledge about that. Christian, can you jump in and help me with that?
Yeah. So first of all, we would have to implement XBus initialization. We basically skipped that. Then we have to learn how to even start executing code on the second CPU. And we have it on our to-do list, but we haven't looked too deep just yet.
Okay.
Definitely, this will be more than just configuration change.
Yeah, so I believe that our plan is we want to have it by end of February if the resources will allow us. So the first goal was just to bring something to the Open Power Summit and show you show all the audience and the world that this is possible. And it took us over 15 months so far. But yeah, but it is possible, definitely.
Okay, yeah, it's very impressive, actually. I heard this was starting. Good luck. But you guys, yeah, you made a lot of progress. I'm very impressed. I guess one other question: you talk about putting this on the occC or the self-boot engine. What would be the advantage of doing that?
So I believe like all the advantage of Coreboot. Yeah, I'm like, this is common code base. Like many people understand that there's big community for that. I don't want to like. I'm not sure what was the design principle to kind of creating dedicated, like I would say, firmware environment for these pieces. And you probably knows that way better than we do. But we maybe don't understand something, and that's why we even talking these things. This is like, newcomers coming and trying something that is potentially impossible or potentially not very good. And to be honest, we even don't know if this would make sense from the Coreboot design perspective. And I believe this discussion right now recently started, because there are some people asking about putting Coreboot on trusted firmware. So if you have ARM platform with Coreboot, and then you have trusted firmware with Coreboots, how this even works? Do we have some complex build environment? How this even cooperate? But yeah, this is rather probably perspective of 3 to 5 years than than something that we can do immediately.
Yeah. Okay. So I guess one other. I don't want to hog all the questions here, but so once if you get this completely done, what do you view as the ease of now? Okay, now there's a P10 chip. Power10's out there. Is it going to be fairly straightforward to support P10, or is that? Obviously, all the hardware procedures and all that stuff changes, right? There's different chips and different things like that would have to be initialized. But would the framework remain as is?
So I don't know, like Christian, do you have? First of all, we didn't touch the Power10 hardware. Maybe we can, like, if we could look at Power10 hardware, then we can say something more. On the other side, I believe there's this community. There is a way to get more hands on the board if needed. And on the other side, there are some people which are interested in Coreboot even on Power10, despite there are some controversy around memory controller and so on, which some of the people, like I believe Insurgo, not exactly. I don't know if Thierry is with us, but I believe he rather thinks about Power9 than Power10. But Christian, can you take on, like, do you know about difference in complexity of supporting for Power10 or other new boards?
I haven't seen actually any of the code for Power10, so can't really say too much.
Yeah, I understand. You haven't seen the differences and looked at it. I was just wondering, but if the whole goal though was is the code design such that you can have Coreboot, which runs and boots everything, and now if you have a new processor technology, that those drivers, if you will, are separated, and someone would just have to plop those in, much like Intel does their FSP, right? Their firmware support package. But the rest of the code would remain the same. You just would plug in the actual details that talk to those new chips.
Yeah, I believe this will take time, and definitely David Hendricks is with us, and he can say how hard it would be to send 15 or 17,000 lines of code to Coreboot. And to be honest, I'm pretty sure there will be many people that saying this is like not acceptable. We have to change this, or we have to relay out maybe to fit better the structure of Coreboot. But Coreboot exists for over 20 years, over 22 years, and like it gathers history from Linux BIOS. So I believe the key point here is the structure is well laid out in Coreboot, and I believe like we will try to fit it as best as possible, and we hope that this will support the maintainability and ability to enable new platforms easily. At least to some extent, people will know, okay, where are these things? Where is this? Where is that? where I have to put this code, where I have to put this driver. Can I leverage some other drivers from the previous platforms? And this is these are things that are well known in Coreboot framework or Coreboot firmware platform, I would say.
Okay, all right, thanks you. Yeah, good talk. I appreciate it.
Yeah, thank you very much. Thank you for visiting us, David.
I think you mentioned something just now that maybe I missed it earlier on. Did you say it would be like a 15 to 17,000 line patch that you'd send to coreboot.org?
Oh, precisely, Christian. Do you know what's the diff right now?
I haven't checked in a long time, but yeah, memory initialization and occC itself is about 15,000.
Okay, yeah, and the reason I mentioned that is I know earlier in your slides you highlighted that Hostboot is like 1.7 million lines of code.
Yeah.
So if I'm doing my math right, that's like a 99% code size reduction.
Yeah, but they support like multiple platforms. It's not like this is like multiple, like there are multiple platforms supported there. But I believe like from the scaling perspective, so also this is like Coreboot is C, Hostboot is C++. There's this like massive machine generated code there. So I believe those are the differences. To be honest, we ported the necessary minimum to boot the platform, and I believe, yeah, this is definitely achievement in terms of like engineering work that have to be done in like I don't know how much engineering work have to be done for POWER9 supporting Hostboot, but it seemed to be this was a lot of work.
Yep. Yeah, and you know, coming at it from the x86 world, I know that a lot of the stuff I'm looking at, you know, from like FSP and everything, about 2/3 of that code could pretty much go away. It's a lot of, you know, UEFI framework and stuff like that. So, so yeah, it's I of course I'm biased. I definitely like the simplicity of Coreboot, and I think that's a huge value add.
Yeah, and I hope that this will prove over time with what we did, and yeah, like hopefully this will benefit community, and hopefully we can find some cooperation with power with companies that bring power machines. Yeah, and hope this will be good cooperation. Like first beneficiary is Insurgo, and yeah, maybe Blackbird will, like, not maybe, there's like we are almost sure that Blackbird will benefit. There are even some people saying that this may boot without any modification or very little modification. So yeah. Okay. Yeah, David.
Oh, I was just gonna mention, since the question of like plugging in modules to support new hardware came up. So yeah, that's something, and I think Peter answered to that point. But Coreboot has grown very, very extensible in that regard. I mean, it's able to support, you know, ARM64, x86, now Power again for the first time in 20 years. So it was really built to be modular and architecture agnostic in a lot of ways. And some x86 stuff has kind of crept in over the years, but we kind of pushed back, especially with the rise of ARM systems being supported in Coreboot. And it's the general architecture it's been very good because since it was originally kind of designed for x86, it was meant to be able to you know, jump between programs at different stages of the boot process. And this proved useful on ARM when we started seeing a lot of SoCs where you'd start out on like a low power ARM core, and then later on you'd migrate everything to a higher power ARM core. So it's really flexible, even in that in how you build it and how you use it, and that it can really adapt pretty easily to various strange hardware configurations.
That's interesting. And so, like with a data file or something, you could say, I want to change. I want 2 sockets, not one. I want more memory, less memory. You don't have to write any code. You can just submit a different config file or something.
Yeah. So So one example I'm thinking of is kind of like the FSP boot flow, where you kind of go in between different programs, like between Coreboot proper and FSP, for example. So if initializing multiple sockets on POWER9 requires such a thing, then it's certainly something that Coreboot is good at. And,
Okay,
and yeah, we can. There are a lot of boards where we make dynamic decisions about things like DRAM configuration. This is fairly common on laptops, actually, because a lot of them, you might have some particular ARM SoC or an Intel SoC, and you want to store multiple possible memory configurations so that you only have to ship one BIOS image to support several different products. So those sorts of things, Coreboot is also pretty good at determining those dynamically and loading different configurations when it detects different variations of what's essentially the same platform.
Mm-hmm. Yeah, there's even good structure in code for that. There is something called variance. So sometimes it happened that, let's say we did this protectly firewalls where kind of they evolve over time. Like there's like almost the same board layout, but CPU change, evolve. Of course, like the other components evolve also, but then the variance gives us ability that sometimes we change only the things that are necessary for given variant. But this is like compile time decision, not runtime decision. There's also runtime decision with which David said about. Yeah, and on the other side, I believe like Coreboot got not bad branding, and like it's over like I believe Coreboot got very good branding in terms of like most of the community, technical community. Like I know for server environment, maybe this is not very important, but for like regular people, Linux users, open source people, like most of them know what Coreboot is, and I believe this is also a big value because, for example, there are many other open source firmware projects, but when customers coming, they typically know what Coreboot is. They don't know what Coreboot is, what Linux boot is, and so on and so on. They have no idea what Hostboot is, or even other components which are in the open power firmware. And like I don't know what, most likely probably they don't have to know. But on the other side, if we want to bring a community and new developers and have environment for learning and for ramping up new employees for development, it's way easier that way than using something which is like hard to learn and like nobody knows where's the documentation and this kind of stuff. So I believe there are some benefits here from name and from community. Okay, so any questions? Okay, so thank you very much for watching this and for visiting this talk, and yeah, I hope to talk to you soon on other conferences. Thank you. Bye bye.